Sweet. Last time was strong acids. Guess what this time is? Strong bases. And we're talking about Wednesday, May 20th. Okay. So, again, in college, you're going to have to memorize which bases are strong bases and which ones are weak bases. But I'm not going to have you do that. I'm just going to go ahead and tell you. So this one right here is a strong base, and you don't name this any way fancy. You name it just like any other salt. So you take the name of the cation and then the name of the anion. So this would be lithium hydroxide right here. And this one would be sodium hydroxide. This one would be potassium hydroxide. This one would be calcium hydroxide, strontium hydroxide, and barium hydroxide. So those are the strong bases. Don't worry about memorizing them because I'm going to tell you if it's a strong acid or a strong base or a weak acid or a weak base when you need to know. So the deal with strong bases is the same as the deal with strong acids, is that they dissociate completely. And remember, dissociate means to turn from one unit with two parts into two units with one part. Yeah? Okay, that's good. So let's see here. Let's take some sodium hydroxide and let's put it into some water. It's going to dissociate into sodium ions and hydroxide ions, sodium ions and hydroxide ions. And unlike with a strong acid, neither one of these is really going to react with the water. They're just going to dissolve in the water just like any other salt, just like sodium chloride. Yeah. It's the presence of a bunch of these hydroxide ions that's going to make the solution basic. Because remember, if a solution has a lot of hydroxide ions, then the solution is basic. So we could take this and you see that nothing happened with the water. It was just sort of a spectator. So we can actually remove the water from the equation and we could look at it like this. Sodium hydroxide reacts to form sodium ions and hydroxide ions. So if we took, let's just say 0.36 molar sodium hydroxide, if I made a solution using 0.36 moles of sodium hydroxide with a total final volume of 1 liter, then I'd have 0.36 molar sodium hydroxide. So if that was the case, just like with a strong acid, there would not be any intact sodium hydroxide in there. The concentration of that would be 0 molar. The concentration for sodium ions, on the other hand, would be whatever the concentration of the sodium hydroxide was before the dissociation happened. In this case, it would be 36/100ths molar. And same with the hydroxide. It would be 36/100ths molar. Yeah? Okay, that's good. Well, what about if we did it with one of these ones that has 2 hydroxides per cation? What about if we did one of those? It would be a little bit different, as you could imagine. So if we started with 0.36 molar calcium hydroxide, then first let's predict what's going to happen here. Probably maybe you guys could go ahead and, well, never mind. So we got calcium hydroxide, we're adding it to water, and it's going to break into calcium ions and hydroxide ions. And then the water, nothing really happens to it. It's just gonna kind of be a spectator. But I think you guys will notice that something is amiss here. Yeah? Probably maybe push pause. What do you think? What is it? That's right. Calcium hydroxide is made from 1 calcium ion and 2 hydroxide ions. The charge on the calcium is actually 2 plus. You might remember that. If not, you can just look here at your periodic table and see that the charge on the calcium is 2 plus. And that's why we need 2 hydroxides, because the charge on hydroxide is 1 minus. So you need 2 hydroxides to balance the electrical charge of 1 calcium. That's why there's this 2 right here, because this calcium has a 2+ charge. And because there's 2 hydroxides, you're going to end up with 2 hydroxides over here also. And that's important because if we have a solution of calcium hydroxide at a concentration of 0.36, then the calcium hydroxide actual concentration is going to be 0 molar. And the reason why is because calcium hydroxide is a strong base, and strong bases completely dissociate in water. So as soon as you put it into water, it's not going to be calcium hydroxide anymore. It's going to be calcium ions and hydroxide ions. And the ratio of calcium ions to calcium hydroxide is 1:1. So your concentration of calcium ions is going to be 0.36 molar. Yeah. But the concentration of hydroxide ions, because there's 2 hydroxide ions for every calcium hydroxide, there's 2 hydroxide ions for every calcium ion, you're going to have double that. So that's going to be 0.72 molar. It's double. You have 2 hydroxide ions for every calcium ion. Yeah? And just in case you were wondering, back when we were doing the strong acid stuff later, you'll notice that one of these strong acids has 2 protons for every, or 2 hydrogens for every sulfate. And it doesn't work that way with strong acids. Only one of these is going to break off. I'm not even going to talk about it, to tell you the truth. But when you're doing it with the acids, only 1 hydrogen is going to break off, even if there's 2 hydrogens available. But when you're doing it with the bases, if you have 2 hydroxides, then both of them are going to break off. If you only have 1 hydroxide, then only one's going to break off. So if I had a solution of 1 molar sodium hydroxide, what would my hydroxide concentration be? That's right, it'd be 1 molar. And if I had 1 molar barium hydroxide, then my hydroxide ion concentration would be 2 molar, because there's 2 hydroxides for every barium hydroxide. I'll give you guys some practice with that, and I think you'll get it. If you need any help, please just text me and I will get back to you. Guys, see you later.